Alright, so there are literally hundreds of ways. There's 3 ways that I know of that you can turn a taper on a lathe. So the first way you can turn a taper is by simply using the compound. So by rotating the compound at close to a right angle, or having this side close to parallel and off by only a few degrees and rotating the tool post, we could actually use this to feed and we could cut a taper. The biggest limitation with using this system is the length of a taper you can cut is going to be limited by the amount of travel you're afforded by your compound. In my particular situation, I probably don't, since my taper's not that long, I probably could have done it this way, except the problem is because I've got this long shaft I'm dealing with that doesn't fit inside the spindle. If the shaft fit inside the spindle, I could just have this small amount projecting from the end of the chuck jaws, and then I could run the carriage down this end and I could actually use that method, or at least attempt it. The problem I have is because I've got this long shaft in here and I've got my study rest and I've got the tailstock right here, I just don't have the room. What's going to happen is if I go to rotate this compound into position to cut that taper, I'm going to end up hitting here on the tailstock, or if I try and swing it this way, I'm going to end up hitting the steady rest. So that's not going to work for me. The second way you can turn a taper on a lathe is the tailstock offset method. So on just about every lathe I've ever seen, there's a way to actually adjust the tailstock so that it is offset off the center line of the spindle to the left or the right. This actual top part of this casting is actually separate from the bottom part that actually rides on the V-ways. And I have 2 adjusting bolts right here. So if I loosen this back bolt and tighten this front bolt, I can actually shift the whole tailstock off axis to the rear. Do the reverse, tighten the back, loosen the front, I could shift it off to the front. What will happen is if this is off the axis, essentially, kind of exaggerated, your piece is no longer in line with the spindle. It's actually kicked off at an angle. So what happens is this end of the rod, if we shift the tailstock this way, this end of the rod or shaft will actually be closer to the cutter as the cutter moves along the carriage. So you end up taking more of a cut at this end and less of a cut down that end. If we move the tailstock, offset it in this direction, exactly the opposite is going to happen. You'll be taking a lighter cut at this end and more of a cut at that end. So you end up with a larger diameter down this end and a smaller diameter down that end. You get a taper. So that would be a good method to use if you have a very long shaft that you want to cut a taper on, or if you do not have the ability to use method number 3, which is using a tapering attachment, because you may not have a tapering attachment for your lathe. I'm very fortunate in the fact that both my 14-inch Vernon and my 12-inch Hendy both have the original tapering attachments. So this is a tapering attachment for this lathe. It's very similar in design. It's almost a copy of the one on the Hendy. I'm not going to get into how this all works because that would be unique to this particular tapering attachment. The basic idea of how it works is the same. You actually release the slide, the cross slide, and the cross slide is able to actually move freely independent of the carriage, but it's when we tighten this lever here, it actually is now bound to this block, and this block, as we move down the carriage, will slide along this bar, which is adjustable, and right now I've got it at a very steep angle, so I've got an exaggerated taper so I can demonstrate what goes on. So as I move the carriage from left to right, you're going to see that that whole block is going to move down that way, and since that block is riding on a track basically of this bar, the block is going to move out that way, and since I've got this tightened, it's going to pull the whole cross slide assembly over with the tool post. So as it moves in that direction, it's going to be pulling the cutter in further on the stock or the shaft, and therefore the diameter is going to get smaller as it gets to the end. So if I move this to the right, you'll see, hopefully you can see that. So I've removed my tool holder and I've installed this Mighty Mag mount with this indicator, and it's kind of obscured by the center rest there. But if I move the carriage from left to right, you can actually see the indicator is changing. Okay, signifying that in fact the whole cross slide is moving in as I go that direction. So that's how we're going to cut a taper. So now that we know that, the beauty is that what I can do, since I already know, remember we talked about that rate of change? Since I already did all those calculations, I can fiddle with this adjustment back here until I get to a point where the actual rate of change measured over an inch is the same as what I measured on that bore, and that should give me a matching taper. So now that I have no reason to believe that this isn't going to work out, that I'll have all my clearances and everything, that'll allow me to use the tapering attachment, what I'm going to do is I'm going to remove the study rest, I'm going to remove the shaft, and I'm going to put a test piece in the chuck, and I'm just going to work down this end with a shorter piece and cut some test tapers. All right, so the first thing I've done is I unlocked the taper attachment, disengaged the taper attachment, and returned the lathe back to normal operation. So the cross slide is now all locked. And the reason why I did that is because I've put a test piece in. This is actually an old prop shaft from a Mercury outboard, and it just happened to be a piece of junk that I got in the scrap pile. But I know that this is going to be a very precision machine piece. I've got a very nice surface to indicate on. So I mount that in the chuck. I put the indicator on it. I make sure that I am in good contact with the side. Okay. Then I move the carriage, and you'll notice there's no deflection, or barely any deflection, of the needle. So what that tells me is that I've got a good, nice, straight shaft that is parallel to the ways, or parallel to the spindle center line. So now that I know that, now I'm going to re-engage my taper attachment, and I'm going to adjust so that I can move the carriage 1 inch and get the same amount of deflection here that I was measuring when I was testing the bore on the mill. All right, this is going to give me a better view of what's going on here. So I've got my Brown & Sharpe indicator stand mounted to the side of the tool post. It's fairly rigid, and I've got myself a Federal indicator with a bullnose contact point, and I've actually got that in contact with the side of the shaft right now. Okay, I backed the cross slide off, you can see. Okay, so I'm making sure I'm in contact, and when I move back and forth, you see I'm getting no change, which is good. That's what I want. So now what I'm going to do is I'm going to preset my taper attachment using the little gauge on the side of the attachment as close as possible to what I think I want, and then I'm going to engage the taper attachment. I'm going to put another indicator over here so I can measure my carriage travel of exactly 1 inch, and we're going to see whether or not I'm going to end up getting how close I'm going to get to that magic number I'm looking for. It's very difficult to see, but there's actually a graduated scale on the side of this bar right here, and there are 3 lines over here. So if I set this line with the 0 to that center line right there, that would be zero taper.
All right, I didn't like it all the way that that was acting with all the flex that I had out there, so I redid my mount for this indicator on the tool post. I basically used a holder and just clamped the bar right in there. So this is a lot more rigid than this was. That should take some of this error out, so I should be able to get better repeatability when I do my tests. If I get to 11 thousandths on 1/4 of an inch travel, I should be right on 22. And it didn't seem like that was panning out. And also, I couldn't come back to where I started and get it to 0. I'm probably still going to have trouble doing that. That has a lot to do with the fact that there's so much play, you know, a couple thousandths of where that block slides along that bar, a couple thousandths where the lead screw moves in and out of that block that is able to move freely, and it all adds up. So I'm at 0 here, I'm at 0 here. Let's try this again.
Three, 4.
There's half an inch, almost 21.5 thousandths. I want to be at 22. I'm still close though. Why am I not getting repeatability though? I don't like that. That's even closer to 22 thousandths that time. $21.5. I don't know. I think that's as good as it's going to get. I'm going to go with those settings right there and cut a test taper, see what happens. All right, I just finished turning my first test taper, and I do a test fit. I can clearly tell that the diameter at this end is too small. I can wiggle it. I can feel it. So it's actually pretty close though. It's not as bad as I thought it would be. So if this diameter is too small, then it means right now it's turning too much of a taper. So I need to ease off a little bit. Yeah, I was pretty close in that last test fit. Well, I can't feel it rocking anymore, so we must be getting pretty close. I'm not sure if I'm bottoming out on this. Yeah, I don't think I should be popping down that far on this thing. What is going on here? I thought that didn't sound right. Took off the tip on the carbide. All right, this ought to be an improvement. I'm getting a lot of chatter, and the only thing that's really different than what I was doing before is that I'm doing this unsupported, so I'm going to face this off and center drill it so I can support it with the center again. Well, that solved the chatter problem, except for one thing. I forgot that when I was facing, I had relocked the carriage and everything for straight turning. So I started cutting about halfway, and I'm like, there's no taper. Oh. right, so I'm getting ready to cut the taper. What I've done so far is I turned down this section right here to the major diameter of the taper. And then I turned down, what I did was I used a red Sharpie. That's what this coloring is right here. It looks like copper. I used this red Sharpie on here so that I could scribe a line, and I turned down this section right here to the minor diameter of the taper. So now I'm going to start from here, and I'm going to cut my taper going in this direction, and I should be able to create the taper that I need on this part right here. And then this area left over here is going to be where I'm going to cut my threads. So hopefully this is going to work. So I've got everything now locked back down, the taper attachments engaged, and I'm getting ready to do that. Well, I'm happy to report that the taper fit is really good. It's even better than I expected. Matter of fact, it's so good that just lightly tapping this, seating this down, but putting a collar on here and giving it a wrap with a dead blow mallet, and it gets stuck on there so much I had to use a puller to get it off. So the taper's really good, but right now the wheel doesn't go down far enough. It's actually about 3/8 short of where I need it to come down to. So I've just got to cut the taper further back, and I think it'll be perfect. Well, I think I'm going to stop right there, because that last bit of extra turning, I think that just about did it. So I was shooting for 12 3/4 from this shelf right here to the bottom edge of the bushing that's in the steering wheel, and I actually have 12 3/4 right there. In actuality, I measured from the metal surface here, not this plastic ridge, so there is a little discrepancy there, maybe a 100 thou or a couple hundred thou, but it's not worth it to me to tempt fate just to get it perfectly. The only thing that's going to result in is the steering wheel might sit up a little tiny bit higher off of the column, the top of the column, than it did before. But I just don't want to. I have a habit of trying to dial in and get it perfect, and then the next thing you know, I've taken off too much. So I'm going to not press my luck. I'm going to quit right there. This is with I put a collar on here and whacked it with a dead blow mallet, so that's on there tight. If I want to take this off right now, I'm going to have to put a puller on it. But what I'm going to do now is, now I'm going to take a measurement and see exactly how much of this is sticking up above this surface right here, so that I can start calculating the area that I want to thread. But it's looking good. I got plenty sticking up. I've got plenty enough sticking up above this area right here to clean that up and cut myself some threads. Well, time to figure out what I want to use for a thread on that shaft and a nut. This is a nice, good, healthy nut here, and would love to use this. Problem is, this is 3/4 10. I checked it with my thread gauge. So the problem is the major diameter is going to be 750 or thereabouts. Yeah, about 740 thou. And unfortunately, the diameter of the shaft I've got is about 722 thousandths. So 3/4 is not going to work. Next size would be 5/8, and There's two standard sizes in 5/8 for fine thread. There's 18 inches, 18 threads per inch, which this is an example of that. Unfortunately, I don't have any nuts this size that I could find. And I'm not too crazy about using this anyways, because although this would give me more threads per inch in that small area that I have to actually thread, I think the coarse threads are going to have more holding power and less potential for tear out. So this is 5/8 11, so this is 11 threads per inch, and I do have this piece of all thread, and there's a nut that I can use. And what's great about this is that the major diameter of this is about 615 thousandths, and I think I'm at like 622 right now. So that's pretty good. So I've got this little area faced on the edge here, on the end of the shaft, and I use that as a place to put my depth mic, and was able to measure to this surface right here, and I get about 620 thousandths. I'm going to round that up to 625, and that way when I take the steering wheel off, I'll know exactly how far from the end down I want to go before I put my I want to put my little undercut notch. All right, I've got a grooving cutter in here. It's just a piece of high-speed steel. It's got a bull nose on it, and it's narrow. I've got that in a adapter so that I can hold it in my big CA holders. And I set the side of this cutter over from this face 600 thousandths. That should give me enough room here to put some threads on. I set my calipers to 600 thousandths, so the bottom of that groove I'm going to make it 600 thousandths. I'm just sneaking up on it. This is not super critical if I go over. And I did. That's how fast that can happen. Like I said, it's a good thing that's not super critical because I went down to 586. Well, as anxious as I am to move along with this project, I am gonna TIG weld some more on this. I just don't like the fact that this is such a short section right here as it is, and then as I rotate this around, there's a big chunk in area in here that's kind of missing. So if I build that out and then I turn it down, I'll have I think much better threads there. I think that should suffice. Alright, so I checked my machinery handbook, and the major diameter that I want for a 5/8 bolt is 625 thousandths. And I just measured this and I got about 725 thousandths, so I'm 100 thousandths over right now. Switch to a micrometer now. I don't want to rely on the calipers. I want a more precise measurement because it's a little more critical. Alright, so I'm setting up the lathe now and getting ready for threading. So I'm just going to loosen the tool post up a little bit. Extended the quill enough so I can bring this flat face on the Polaris tool post right up against this side of this quill. And that's just a quick and easy way for me to square the tool post. So now this, because this face is exactly 9 degrees from this face, now my tool is going to be perpendicular to the center line of the spindle. For more accuracy, it's if I'm working down that end, you do it right up against the face of the chuck, it works really well. But since that's way the hell down the other end and I can't get down there because of the study rest being in the way, we'll just use this. So now I got all that set, so grab my threading tool. I only have one threading tool. Oh, I forgot, that's completely pointless for me to square this up because unfortunately the only threading tool that I have is this one here. So last time I had to cut threads, I just mounted this in one of my Alloris holders. But the problem is, obviously, that's not going to be at the right angle. So I need to, well, this is going to be a pain because I need to set this, and I can't use a fishtail gauge to set this because it won't fit in here. Let's see. Alright, hold on. I should be able to figure something out here. Well, I'm disheartened by the fact that I'm stuck because I can't figure out any orientation where this is going to work short of me extending this holder way out of the Alloris holder, so it would be hanging way out here. The problem is the corner of the tool post right here is hitting the quill and it's going to be interfered with, so I've got no way to that I'm going to be able to get this over to thread into here unless I push this way over this way and, like I said, extend this out. I don't like this at all. And I know that the easiest way would be is if I had a proper carbide threading tool insert that I could put in this holder. Yeah, I know. I can't believe I don't have one. So the reality is, I've been meaning to get one anyway, so I think I'm just going to pick one up. So, I don't know, depending on how long the videos are at this point, I might just conclude this part right here, and then pick it up when I get the new threading tools in.